Hi, today we're going to look at special right triangles. We have learned about the Pythagorean theorem, which we can use to find the missing side of a right triangle. But today we're going to look at two special cases. One is the 45, 45, 90 right triangle, whose angle measures are 45, 45, and 90. And the other being a 30, 60, 90, whose angle measures are 30, 60, and 90. The first thing we can notice about a 45, 45, 90 is that it is isosceles. Since the two angles are the same, that means the two legs in this triangle are the same. So let's say that this side over here is 5. Whoa. I'm going to teach you a method that I call divide in and multiply out. Divide in, multiply out. The ratios of the 45, 45, 90 triangle are always 1 to 1 to the square root of 2. So if we start with the side that we were given, the 5, we can divide in, because we're outside of the triangle right now, we divide in. 5 divided by 1 is 5. And now we multiply out. So to find this leg, we multiply 5 by 1, which gives us 5, which is good since we knew this was an isosceles triangle. And then to get our hypotenuse, we would take 5 times the square root of 2, which would give us 5 radical 2. Let's look at another example of a 45, 45, 90. In this case, let's say we know that our hypotenuse is 6 radical 10. Again, we know our sides are in that same ratio. This is what they'll always be, 1, 1, and the square root of 2. So now, as we are starting with the 6 radical 10, when we divide in, we're going to be taking 6 radical 10 and dividing by the square root of 2. And this would become 6 square root 5. And then we would multiply that by 1 to get both sides of this triangle. So you can see we can do this with radicals. If this number was not a radical and we would divide by the square root of 2, we would have to rationalize the denominator. Now let's take a look at the other type, a 30, 60, 90. The ratios for a 30, 60, 90 are different. Across from the 30-degree angle would be 1. Across from the 60-degree angle is the square root of 3. And across from the 90, the hypotenuse gets a 2. So let's say that this side, let's say the hypotenuse is 14. We're still going to do the same process, divide in and multiply out. So I'm going to start with the 14, divide in by 2, that would give me 7 in the middle. And now I multiply out. 7 times 1 means our short leg here across from the 30-degree angle is 7. And 7 times the square root of 3 means my longer leg here would be 7 radical 3. Again, these ratios will not change for the 45, 45. They will always stay 1, 1, and radical 2. For the 30, 60, 90, they will stay 1, radical 3, and 2 for the hypotenuse. All right. Let's take a look at one more. Put my ratios on here first. 1, radical 3, and 2. And this time, let's say that our longer leg is 18. We need to divide in, so 18 divided by radical 3 we would have to rationalize our denominator. So we would take the square root of 3 and multiply on the top and bottom of the fraction. We would get 18 radical 3 over, if we multiply the square root of 3 times the square root of 3, we would get the square root of 9, which is a perfect square. So the square root of 9 would come out as a 3. And then we can divide the 18 and the 3 here. So 18 divided by the square root of 3 would be 6 radical 3. And then we can multiply out. So we've divided in, now we multiply out. 6 radical 3 times 1 is 6 radical 3. And 6 radical 3 times 2 is 12 radical 3. So that's the process using the ratios of the sides of special right triangles to find the missing side lengths.